So this is going to be just a quick little review over everything that we've learned so far with geometry. We're going to talk about angles, angle relationships. We're going to talk about triangles and the triangle sum theorem. We're going to talk a little bit about cross sections and a little quick, snip on the triangle inequality that we talked about this week. So we're getting prepared to take your first test digitally. So you need to make sure that you are keeping up with all of your material so that you don't fall behind. The test will be done through SchoolNet just like we do in class. So you want to make sure that you are keeping up with everything. Make sure that you check out the Zoom session this afternoon as well, so that way you can ask any questions or receive any feedback that you need. Okay, so I'm going to go ahead and flip the screen over to a little something different, trying to keep things up. I know it gets a little bit boring, and I'm sorry that you guys are stuck at home, but bear with me. I'm going to try something new today, okay? All right, so let's first talk about our angle relationships. So with our angle relationships, we have one thing that's, if we're talking about complementary. So complementary angle relationships, and I'm just going to put comp there. We know complementary is supposed to be equal to 90 degrees. So we want to make sure that we understand that. Now remember, complementary angles form that L shape. Okay, so it kind of has that L. It might look like this, or it might look like this, or maybe this way, or maybe it'll look this way. But the idea of it that when you have complementary relationships, you have two angles that are going to form this L shape, this 90 degrees. So maybe I have another little line that's going through it, and this angle is angle A, and this angle here is angle B, and the idea of it is that if you take angle A and you add it with angle B, it's going to be equal to 90 degrees. Okay, so that's the idea of our complementary angle relationships. So then we've got our supplementary angle relationship. So I'm just going to put sup. Okay, and we know supplementary angle relationships, they're going to come out to being 180 degrees. 180 degrees. So they're just going to form a straight line. And then they'll be separated, by one or two angles that are going to pair them up together. So maybe we have a little split here where we have angle A and angle B, and all we have to do is take angle A and add it with angle B, and this is going to be set equal to 180 degrees. That's our supplementary angle relationships. Okay, then we talked about our vertical angle relationships. So with vertical angles, remember, it's kind of like you're talking about neighbors. So if I've got intersecting lines, and this is angle A, this is angle B, here's angle C, and here's angle D. Vertical angle relationships mean that if I start at angle A and angle A decides to poke their head out of their door and they don't turn and look left, they don't turn, they don't look right, they're just looking straight ahead. So that means they're looking straight ahead at that center vertex point. They want to look at this vertex point and then continue to look straight ahead of that. What angle are they going to come to? That's going to be angle C in this case. Notice that I did not curve. It did not turn left. It did not turn right. It looks straight ahead past that vertex to the next point or the next angle. That's a vertical angle relationship. So angle A is equal to angle C because vertical angles are equal in measurement. They are equal to each other. Okay, so vertical means congruent. means equivalent, means the same, it's equal. Okay, now A and C are not the only pair of equal angles or vertical angles, because notice B can also open their front door, look out their front door straight at that center point, and continue to go right past it to angle D. So angle B and angle D are also going to be vertical angle relationships. They are set equal to each other. Okay, so those are the angle relationships that we talked about. We also talked about the triangle sum theorem, and the triangle sum theorem states that, hey, if you've got a triangle, and this is angle A, and this is angle B, and this is angle C, then if I take A and I add it with B, and then I add it with C, what do I get? I get 180 degrees. It does not matter what kind of triangle you have. It could be a right triangle, an obtuse triangle, an acute triangle. Maybe A, B, and C are all the same. And in that case, if they're all the same, then they would all have to be 60 degrees because it's always going to equal a sum of 180. Right? Then we go to our cross sections. So for our cross sections, I'm actually going to kind of come out of that screen for a second so I can show some things to you. So let's say I have this piece here. This is a cylinder, okay? It has a base shape that's a circle on both ends. And it basically is kind of like if I took a rectangle and wrapped it around it, that would make our cylinder here. So three-dimensional shape. If I were to go ahead and slice my three-dimensional shape, slice it downward, which would happen to be perpendicular to the base shape, perpendicular, that would mean that it's going to cut it open and you would see a rectangle. If I were to cut it parallel to the base, so I wanted to shave a slice off. Think of you have a thing of salami. Okay, you're cutting some salami and you're cutting slice and cutting slice and cutting a slice. Cutting those slices, that's creating a cross section right there. When you cut, deli meat or anything of that sort, it's creating a cross section, and that little shaving that you're going to get off is going to be that circle there. So if I'm cutting parallel to the base, I'm cutting parallel to the base. That means that the base is going to stay intact. It's not going to change. Okay, so when you cut parallel to the base, you always get your base shape. If you cut perpendicular to the base, you're going to get a rectangle if it's a prism, or you're going to get a triangle if it's a pyramid. Okay, because the triangle is made up of a bunch of pyramids to connect it all together. So let's go ahead and write that piece of information down. Okay, so for cross sections, ooh, so sorry, I'm having to use a mouse to write this with, and I do apologize, but I just wanted to try a little new program here for you guys. Okay, so for cross section, if you have a pyramid, we'll do a pink. Or actually, we'll do a prism. So let's say that we have a prism. So with our prism, if it is parallel, you're going to get the base shape. Parallel is going to be the base. So if it's a cylinder, your base shape is a circle. If it's a cube, your base shape is a square. If it's a rectangular prism, your base shape is a rectangle. A triangular prism, the base shape is a triangle. Whatever the prism is going to be, it's named based off of its base shape. So the base is the cross section you'll get if you do a parallel cut. If you do a perpendicular cut, that's a little bit different. Let's erase that. So if we do a perpendicular cut, then that's going to give us a rectangle always. Prisms are made up of a bunch of rectangles connecting to their base shape. So, sorry. Okay, so we'll just call it perpen. Perpendicular cut is going to be a rectangle, always. Okay, now if we're talking about a pyramid is a little bit different. Okay, so for a pyramid, with a pyramid, you have a bunch of triangles that are connecting from your base shape up to a point. So it kind of looks like, maybe you have a cone. That's a kind of like a type of pyramid. Okay, you could have a square for your base shape, and it's going to have a whole bunch of triangles that are going to connect it to that top piece. Okay, it's a little bit different than what a prism would be. So if you've got a parallel cut, so a parallel cut is going to give you your base shape as well. So it might be a circle, it might be a triangle, it might be a square, but if it's a perpendicular cut, okay, that means it's going to slice through the base. That's always going to be a triangle. A triangle will be your cut there. Okay, so that's your cross section. Now, with a sphere is the only shape that it does not matter how you cut it. A sphere is made up of nothing but circles. So no matter how you cut a sphere, you'll always get a circular cross section, a circle for your cross section. Okay? All right, the last thing that we're going to go ahead and talk about is going to be the triangle inequality theorem that we learned yesterday and the day before. So we learned it on Monday and we learned it on Tuesday. So we're going to talk about that real quickly. So we talked about how if you take the two smallest sides, so you have three sides. If you take the length, the two smallest, so small a, we'll call it small a, and you add it with the other smallest side, so small b, that measurement needs to be larger, it needs to be greater than your largest side. So we'll call it large C. Okay, so if you add A and B together, your two smallest measurements together, it has to be larger than your largest side. So let's say that I have 6x and 15. And we'll say 15 is my largest. I want 15 to be my largest, so I'm going to put largest right here. That means that x, when I add 6 and I add x with it, that sum has to be greater than 15. So I need to know what x is going to have to be. So if I subtract 6 away from 15, x has to be greater than 9. It can't be equal to 9. It has to be greater than 9. So that means x could be equal to 10. It could be equal to 11. It could be equal to 12. It could be 13 and 14, whatever it wants. So 10 would be a perfectly fine number because 6 plus 10 is 16 and 16 is greater than 15. It can't be equal to 9 though. Even though 6 plus 9 equals 15, it cannot be 9 because it has to be larger than 15. You have to have a sum greater than 15. Okay, so that was our triangle inequality theorem. So what you guys are going to be doing now, you're going to do some practice again. It's a quick quizzes. because I want to see what information do you know, what information do you not know. And then after you take that quizzes activity, you're going to make a posting of what questions, what types of questions do you want to see more practice on, so that I can create Thursday's lesson based off of the questions that you have. Okay, if you've been doing really, really well on everything, that's great. I'm very, very proud of you. But I still expect you to make a posting in the discussion board of questions that you would like to have more practice on. Everybody can use some more practice. And then you need to make sure that you're getting prepared for your test. Your test is going to be next week. If you haven't done anything for our digital days, you have a lot of catching up to do, because you need to get this stuff completed so that you're prepared for your test. School is going to be done this way from now on, guys. So we still are testing. We are still taking a geometry test. We still have a real numbers test, and we still have a final exam. So please make sure that you're keeping up with your material. Have a good night.